Well, if it isn't the weekly Monday morning 11 to noon vlog podcast with the Santa Barbara Astronomical Unit, well, it's a podcast if you're listening. If you watch us, it's a vlog. It's SBAU, the Santa Barbara Astronomical Unit, presenting the SBAU Astro Hour. And doggone, we are California's Santa Barbara anyway, longtime astrophysics and telescope club, headquartered up in Mission Canyon at the Santa Barbara Museum of Natural History. We hold our monthly general meetings for members and our second Saturday star parties. We do have a lot of fun doing the club and here on the SBAU Astro Hour. Love to have you join us. I'm your cosmological host, Ron Heron. I'll introduce you to the rest of the guys. This is our 172nd program since we started 3.5 years ago, March 1st, 2021. Check us out, please, on sbau.org. Watch us weekly and even comment or ask questions on YouTube. Above all, tell your stargazing friends about the astronomical unit. Hang on, we'll meet the guys, but here are today's Astro headlines, the topics we're going to try to get to. Well, it's the Southern Delta Aquariids meteor shower coming next week, but we can see meteors every night, pretty much, they say, depending on whether you have our weather or out in the desert. What are ice giants? And where are they? How do they compare to gas giants or us little rocks? Comet 13P Old Bears is in the far western sky. Boeing has joined the space race. Did it without duct tape on the doors again. A big success for SpaceX, the biggest spaceship ever launched, and they got it back. And the European Space Agency's Euclid scope in space, it's a space telescope, it's also doing good. China's Chang'e 6 is on its way back from the lunar surface, the other side, with some incredible stuff on board. Let's meet the gang. Captain of the Starship, the Captain Kirk of SBAU, is our own beloved President Jerry Wilson. Hi, Jer.
Good morning.
And your lovely wife is Pat Forgy, big supporter of mine. I assume all the wives are listening nearby or watching us, as are the club. Chuck McPartland is an incredible outreacher. He is in charge of all the events, the short range events. Merchandise manager is his wife, Pat. She's also our treasurer. So they're both married to Pats. Tom Whittemore is on board. He's married to Maureen. Hi, Tom.
Morning.
And it's our newsletter, puts it out every month. And apparently doesn't miss Westmont except on the third Friday of the month when we meet out there. That's all right. You put in your time. Bruce Murdoch. Oh, incidentally, Tom's married to Maureen and Bruce is married to Bonnie. And hello, Bruce. How are you?
Hello.
Yeah, you and I both
Oh,
thought the
my hand
same
raised.
thing. What?
I,
You're doing
I,
okay?
I was waving at the wrong place. My hand didn't show.
That's okay. He actually takes. Uh-oh. Turn me off. You're driving.
Bruce, you're feeding back.
Yip, 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 yip. Sha-da-da-da.
Well, let's just kill this other one.
Kill that other one.
Uh-oh.
AR's 15. Are you guys
Well, I
going
lost it on the big screen. That's what
Uh-oh. We have a Houston. This is Apollo 13. Bruce is married to Bonnie, and he's president of the Santa Barbara Theater Organ Society. And I hope you didn't mute yourself. Are you?
I
muted?
did.
Yeah.
You're okay. Okay. And then there's Tim Crawford, who's married to Karen, telescope expert. Yes, sir. Captain Lens. Big part of Tuesday. I guess Tuesday we have our big workshop tomorrow night, along with something else. Oh, we'll be out at Telescope Tuesday tomorrow night.
Ooh.
Captain Jerry, our president, sends us these silly science cartoons, and I tell you, we enjoy them.
Okay.
There is an archive going back 3.5 years. There's thousands of these things. Let's go to the.
Okay, just a sec. Bruce, when you think you've got the feedback loop cut off, you can unmute yourself.
Uh-oh. Yeah. You were fine earlier. I don't understand that.
Well, you weren't talking, Ron. That's what.
Is that what it was? Well, okay. All right. The most amazing. Are we doing?
Do you have feedback now?
Yeah.
Yes.
It's still repeating myself. Well, I'll just echo. Hello, here in Grand Canyon. Yes, we're looking at the most amazing display of cooperation in the history of man. How we always wondered about Thousand Island dressing. How did it manage to come together and agree on one single dressing? was those last three islands that got involved. Otherwise, it's going to be called 997 islands. Here's another rare statement from the Galileo Galilei. The longer I live, he said, the more convinced I am that this planet is used by other planets as a lunatic asylum. Right now, you're looking at the rumpus room with us. This is a good one. Took me a while. Maybe you guys got it immediately. Where in the world do astronauts hang out? Anyway, he's sitting at a keyboard down at that long, wide key that we use for anybody?
Space bar.
Space bar.
Oh, now I get it.
Well, wait till you get to the Samuel Jackson one. That's the one I haven't figured out. Now, this I thought was a Mobius strip, and so did Bruce, who has, I guess, left the screen. He can't get rid of it.
I don't know what this is.
Well, it's a blanket when you're trying to get the wrong side up at 3 a.m. That's what mine looks like. But
Yeah.
could also be a futuristic Mobius with several other dimensions, I think.
We'll have to ask AI.
We've all made Mobius strips. Here's the little visiting alien inside his spacecraft coming up behind two of our airmen inside an F-16, taking a selfie, and he is babbling something in his extraterrestrial language. And the guys say, okay, now they're just messing with us. As he goes click, and he's
The asterisk up here and then the asterisk down here.
yeah, right. I finally figured that out. That's what he said.
Okay.
Cheese in volcanism or whatever language he uses. That's a good one. That's a well done one. SAC, is that the name of that?
Yeah.
All right, this one needs some explanation. I can see Samuel L. Jackson on the left. This is the best chemistry meme. Okay, so it's a chemistry thing that we've seen, and we can't stop laughing. Hope this goes chiral.
Chiral. It's chiral, and it means handedness.
It's chiral, actually.
Chiral. Okay.
Chiral.
It's
Oh,
like
I've heard of
Celtic
chiral.
or
Okay.
Celtic.
All right, that's nothing to do with twins. It's just what, backwards?
It refers to isomers. So when you have the same molecule, but it can it has slightly different forms that can rotate polarized light either the left or the right. Otherwise, it's chemically very similar.
Does it have
The
to?
reason it's important for life is that we seem to be, I think, L isomers of things that work for biology, but most biology does not use the D isomers.
Okay, so Samuel L doesn't stand for left, and it
No.
should be Samuel R for right, but that's what I was reading into it. Okay.
Well, it is left and right, but it's in Latin.
Yeah,
Yeah.
it's an in joke for biology.
I'm curious if it's similar to an old CSI Vegas show I once saw where they looked at what's it called? It's two people born without some kind of gene.
Chimeras, right.
Chimera.
Albinos?
Does that have
Well-
anything to do with this? It doesn't have
Nope.
anything to do with human egg cells.
Nope.
Okay.
Well, in those chimeras, they actually are. There were two separate fertilizations that made one human. So one side of the body is different than the other side genetically.
Is that what it was?
Yeah.
I don't seem to recall that,
Well,
but
that's one of the things that happens.
all right. Well, the real intelligent chemists laughing like crazy to this. And here's several versions of the maestro in charge of the symphony. You have your regular conductor up in the upper left. Then there's a semiconductor, a little bit of electronics here, and the superconductor. Where's the cape?
Yeah.
Who would have thought?
I didn't see that.
Oh, you didn't see that.
I
Here's
missed a lot of them.
This is an old horsey saying, which is sort of updated, and I agree with it. You can lead a human to knowledge, but you just can't make him think. That's well done. This one needs some explanation. We all know who the scientist is on the upper left playing the violin. As doesn't have his hair sticking straight out. I guess
This
Einstein
one
was
is
the-
Max
What?
Planck.
Max Planck and Richard Feynman.
Okay,
And,
who's on the guitar?
This is Mays, I forget his first name, from Queen.
Brian.
Brian, thank you. And he has a PhD in astrophysics.
Yeah.
He does.
Mhm.
Yeah.
Whoa.
Yeah,
Okay.
he came back after playing with Queen to get it.
Yeah.
He took time off to be a rock star.
Okay.
To be the old guy in the room.
All right. Give me
That's right.
for 10 years on your life, give me one Queen song you remember.
We Will Rock You.
Okay, that's
We are the champions.
We are the champions. That's a good one.
that's it. You got it.
So one time I took a class from Richard Feynman, and he does play the bongo, but he told a story about he was in South America and they were at a nightclub and he took the bongos and he played the bongos for everybody. And then they wanted him to they liked what he did, and so they wanted him to do a set with him. And he said the problem was they wanted me to do the same thing I just did. And he said, I make it up as I go along and I don't remember.
Yeah. Yeah.
And you, Mr. President, you provided the day-o, day-o. Daylight come and me want to go home. Apparently the Macs are supporting Windows these days.
Macs have been able to run Windows for a long time.
That picture is a big pain in the pain. And here's the Japanese spacecraft. Dinosaurs, consider yourself avenged, because the Japanese sent out a lander or something that fired a bullet into a rock in space after 65 million years. You've been avenged. We even sent more, a whole space probe into one. Why didn't we get
slammed a whole space probe into one?
That's true. And we talked about it on this very program. Should be interesting stuff. I'm not sure where you're going to start, but if you do, like on your talking points, Mr. President, it's the coming meteor shower next week. And the fact that there's meteors every night. Is that true? Do we ever see them on star parties?
Yeah,
It's
sure.
just chance.
When we were up at our favorite location on East Camino Cielo, we saw a lot of shooting stars.
Yeah.
Hate to say this, Bruce, but you look so better when we can't see. Never mind. Never mind.
Are my videos off?
Yeah, we miss you. We miss you, but
Let's
that's
see
all
what
right.
I can do here.
I had to do it once without my ugly face. Now, this is a piece of space dust or a meteor. This is a meteor, right?
This is a meteorite. Well, it depends. This might have been captured in space.
Okay.
This actually looks like the filters they use on U-2 aircraft that go up and collect these
Okay.
stuff.
So we have definitions of meteoroid, meteor, and meteorite. But which one applies when you go up and you catch it?
Or never comes to Earth.
What would that be? A
A meteoroidite.
A meteoroid.
meteoroid.
A meteoroid caught. So this is that you can tell from the 1 meter, 1 micron
Micrometer.
bar up there. This is a very small meteor. When you look up at the sky and you see a meteor streak by, the real fast, bright white ones that go out real quick, and nobody can turn their head fast enough to see it when someone yells, "Oh, a meteor!" Those are usually about size of a marble or below, dust grain to marble size.
Well, they'd go right through you, wouldn't they?
If you were up there, a marble, it hits you, what, it's 30,000 miles an hour. Yeah, it'd hurt.
Well, we're still talking about gazillions of atoms, or if not molecules. Is it one big molecule or a bunch
No,
of
this is way bigger than a molecule.
Okay, so it's a bunch of metals put together, or are they sometimes just copper or iron?
Well, it could be a mineral.
Yeah, it's not necessarily a metal, Ron, although astronomers call metals weird things. So
Yeah. In condensed matter physics, my field, a metal is something with the conduction band half filled. That's a metal.
If this was in our hand, would we be able to see it?
What's that?
Could
You
we
could not see
this
this.
if we were holding it?
No.
If you had a
It's
microscope,
49
yes.
millionths of an inch.
Yeah.
1 micrometer.
But it would make a flame in the sky that we could see.
Briefly, yes, you'd see a flash.
Wow.
You said 40,000. In your write-up, I think you said 70,000 miles an hour, 72,000.
It's like 45,000, I think. That might have been kilometers, 72,000.
It's above.
Okay.
I was just trying to get a number above orbital speed, 17.5. And so as I recall, they're usually in the 30s somewhere.
I get
It
it.
could be anywhere.
This would be a Rytio meteor.
But this is usually the remnant of a passing comet.
Can be.
Can be. Well, the ones that come from the radiance are, I guess.
I like this diagram.
This is that thing in the center is the Earth. And this is the debris rings around us. And any of these particles, if the orbit included our atmosphere, would be a meteor. You would see it.
Wow.
Do I hear feedback again?
Here's something going on.
Yeah.
Is that
That's
me?
Tom, that's Tom
Somebody
talking
talk
to
in the
Maureen, I think.
background.
Oh.
Okay,
Hmm.
good.
So that's not space debris. That's the little tiny things we just saw.
No, this is stuff we've added to space.
Yeah,
Oh, this is the debris. This is,
yeah. This is debris, yeah.
oh,
Well,
But
Free and active satellites.
the dark thing in the middle is all of the low Earth orbit satellites, right?
it's
There are too many of them.
where our military shoots satellites out of the sky to show off.
okay.
And
But
so-
if any one of these things falls out of the sky, we get a meteor, don't we? It'll burn up, it'll flame out or flame up, right?
Yeah, the space debris sometimes is quite large, and heavy, like a battery pack, and some of that will make it, a small amount of it will make it to Earth.
Or a reaction gyroscope. They've got fairly large wheels.
Yeah, so
Gee.
but any of these can be a meteorite if it hits the Earth. There is, in addition to that, there is space dust that's natural before we put any of this stuff up. And any of that stuff can float into our atmosphere. And we generally get, what is the number in there for tonnage per year?
I've seen 50 to 100 tons a day.
Okay.
That are added to or that we get back?
Added
Well,
to.
That's why they have to dig out archaeological treasures of, thousands of years ago. They get covered up with the dust that comes in every day.
Wow.
25 million meteoroids, micrometeoroids, or other space debris enter Earth's atmosphere each day.
Jeez. Okay. Well, can I ask my silly question again? Remember I asked about nebula and the
Yeah.
gas and the dust, and you explained the dust. We're not talking about what we just saw, the little micro item, right? That's not the same kind of dust that makes up these nebula clouds and distant.
No, it
It's the
sort of
same
is.
stuff. Same
It is.
stuff. It's all over the place. Our galaxy is full of it. If there's some perturbation, like a shock wave going through a star, goes through at a high speed, it will cause some bow shocks in that dust, and it will start the process of gravitational collapse, which could end in a star or a planet or a planetary system. Same stuff. It's spread all over the place.
And Chuck, did you say 50 tons or more
50
than
to
that?
100 tons a day.
50 to 100. Wow.
But
The
by
Most
any,
of it's really small and just sifts down and ends up as dust, and most of it ends up in the ocean.
by any chance, did any of you hear about a big rock hitting the ocean near Indonesia? Not Indonesia. What's the big tropical island that's divided in half?
New Guinea?
What is it?
New Guinea?
Yeah, New Guinea.
Okay.
In 2014.
This is that one that Avi Loeb was saying was an interstellar spacecraft, and he was
That's what it
collecting
was.
pieces.
Yes.
Yeah.
And it turns out some of the seismic information he was using to try to locate where it came down came from a truck driving on the dirt road.
Okay. That could be a cartoon from Jerry, that one.
Yeah, we just
So
Well,
the Wikipedia claims that we get 15,000 tons of random meteorite and space debris per year. The Earth continually gets heavier.
Well, do the math. What Chuck said times 365, I guess.
Close.
Okay. Amazing.
Now, when we were at CalStar, which is the end of the year star party in California, up at Lake San Antonio, usually around October 1st, magnificent skies, almost always dark and clear. My son and I were up there, and he said, "Oh, there's a big meteor right there." And I said, "Where is it?" And he pointed right where I was looking. I stopped looking for meteors after that.
Well, we stopped calling them falling stars. I went out with the Pinocchio play, I guess.
I've actually been asked if we were going to run out of stars because they kept falling.
Well, that 5-pound sucker that you do the soliloquy with in your hand at star parties, did that start out as something even bigger?
That had to come from an asteroid on the order at least 100 miles across initially.
Okay,
It
I
got
know
broken
that.
up in a collision.
It weighs about 5 pounds, but do you suppose it weighed 10 or 12 or 15 before it hit the air
Well,
atmosphere?
no, it was part of a 95-ton meteorite that detonated in the upper atmosphere.
Oh, okay. All right. What are we looking at here? Ah, it's time for ice pool.
We're looking at the four giant planets in our solar system. Two of
Okay.
them are gas giants, Jupiter and Saturn, and two of them now are officially called ice giants. Not because of any Marvel movie, but just because of their composition. Jupiter and Saturn are made almost entirely of hydrogen, which is a gas at these temperatures, or a solid in the core and under pressure. But Uranus and Neptune have molecular gas in them, which at the temperature that the planet is at, these become ice or some kind of slush.
Huh. But some of them are hot, aren't they?
Oh, in the interior, they're all hot.
They're all hot due to their internal forces, not the
most
sun.
notable in my view is Jupiter. It still has residual heat, they all do, from collapsing and gravitationally being compressed. That causes frictional heating, and the heat can last for a long time. The heat's got to work its way to the surface and radiate out. Jupiter has not gotten rid of all that heat yet, and it actually emits more infrared radiation than it absorbs from the sun. So it's actually a source of infrared radiation. JWST has taken some nice pictures of it based on its own emissions rather than light from the sun. But Saturn doesn't too.
The reason Uranus and Neptune are called ice giants is not because they're heavy on H2O. It's because it's slushy and
It's because it's not primarily hydrogen, but instead other things like methane and ammonia.
Right. Have higher freezing points.
okay, I guess we're the only planet in the solar system that's technically a water planet. There couldn't be a water planet this size on the screen here, could there?
Not
Depends
quite
how much
sure.
internal heat it had.
Yeah.
Well, there's water moons or
Yeah.
ice moons that are
Yeah.
definitely, but I wonder if something this size of water down deep, it would be so pressed that it would be like ice, wouldn't it?
Yeah.
Well, you see on the Uranus and Neptune, the three color-coded things down there. The middle one is mantle, is composed of water.
Oh, it is.
So it's got water in there, but it's in the form of ice because it's compressed and it's cold.
And it's totally different from ammonia and methane.
It's
which,
mixed with solid ammonia and solid methane.
solid. Those are oils, aren't they? They would float on regular water in a bucket. They're not floating. They're mixed together somehow.
Methane, I think, qualifies as a petroleum, maybe. You get it out of petroleum wells. Ammonia is definitely not a petroleum.
No,
That's CH4OOH. So
Yeah.
they used to use that as a refrigerant.
it's a cleaning fluid, isn't it? It stinks up the house something terrible.
Yeah, it smells very bad.
Wow. Fascinating stuff.
Now, they all have ice cores. That's speculative. The way they determine these compositions is they monitor the path of space probes that go by them, and they see how their path is altered. You can develop a profile of what the gravitational source is and how massive that
taking a
is.
CAT scan.
What's that?
It's like taking a CAT scan.
Yeah, as long as they're not claustrophobic, yeah.
Yeah, but this is a gravitational scan.
Well, I'm glad
Right now,
okay, let's go to the sky.
Right now, this is the morning sky at 5 a.m. tomorrow morning. Uranus, one of the ice giants, is down here. The other one is up here, Neptune. And of course, you have the sky cluttered with Mars and Saturn also.
Clutter?
Well, for the topic today,
Yeah, right.
planets. Now, neither of these are visual, naked eye stars. You need a telescope to spot them. And you need to go through a little process to find out the suspect, the candidates, and then you blow it up with your telescope magnification. You increase the magnification, and the planet will present a small disk where the stars will stay points. If your telescope is not a very good telescope, all the stars will present a disk.
Or if you've got windy skies.
Oh yeah, that too.
Yeah. Turbulence.
Yeah.
I notice on all these pictures like this, Mr. President, we have a concave horizon. I guess that's to do a fisheye view and get more in from the sky.
Yep.
Yes. If I zoom in more, it flattens everything out.
Got it.
But that's exactly right.
Fascinating.
Now, this is about, there's a section here now about globular clusters in Scorpius. This is a map from the Sky 6 at midnight tonight, but it'll look this way any night. This shows where Antares is. This is, I put the cursor on it because Antares is red, but this planetarium software shows that it's bright white. I was a little disappointed in that. Right here next to it is M4. And actually, it's probably about a degree away or 2 degrees away. It's almost in the same field of view. If you have a wide angle camera or astrograph, you can get them in together.
Or binoculars.
Or binocular. Yeah, definitely binoculars.
I saw
I
it
don't
last
use
night.
binoculars too much because I don't have stable image stabilization binoculars.
And you don't have a sky window.
And I shape
M4 is a galaxy?
M4
Globular
is a
cluster.
globular cluster.
Oh, it's a cluster. Okay. Wrote
So
down
Jerry, are you going to talk a little bit about 6144? Because I've got a fun story.
Yeah.
Okay, so when you come to it, I'll tell everybody a fun story. I think Tim will remember this too from an earlier workshop. 61.
Okay.
Okay. I think you'll remember, Tim.
I think this is 6144 right there. Isn't that?
I thought it was on the same side as M4.
Yeah, it kind of is. See, there's Antares, M4.
Okay.
And there's,
Okay.
you know,
It's just not, it isn't marked.
no, it's not a major object. This is the M4, a very dense globular cluster. And this is 6144,
Yeah.
a very sparse globular cluster.
Actually, M4 is pretty sparse too compared to most.
Now, not compared to
But
this,
it's
though.
binocular object.
Yeah.
I got it last night.
6144 is a globular?
Yeah.
Yeah, it surprised me too, but that's what they claim.
So Tim, okay,
Uh-huh.
Jerry, do you mind my little story? It's pretty cute. So in one of the earlier workshops when Ed Edwards was coming, working on a 6-inch mirror that he started as a little kid. I think he never finished the mirror during the workshop time he was spending with us. And he told us a story that was kind of neat. So like you, Jerry, he was raised in the Los Angeles area, and he used to go to Griffith, okay, because there were some nice astronomers I think he'd like to talk to a lot. And one night, he and a friend of his claimed they saw a comet near M4. Remember this one, Tim?
I do.
Yeah, okay. They thought they saw a comet near M4. So they went up and reported this to one of the astronomers at Griffith. And he pulled out one of those old Czech 1950s star charts. Do you remember Chuck who wrote those, the Czech ones?
John Manick or
No, it's like a 2-syllable name. I almost want to say Kelso, but that's not it. But it's
Oh, the Skalnate Pleso.
Skelnick. That's it. Yeah,
Skalnate Pleso. Yeah, okay.
that's it. So anyway, when the astronomers said, "Wow, you guys discovered a comet," and they said, "Oh yeah, we saw a comet. It's up near M4." And by the way, M4 can be easily seen with an 8-inch, but 6144 is tough. You can't do that.
Oh, okay.
So the guy pulled out a map and he showed him 6144, and he says, "This is your comet." So that was kind of the end of the story. It's pretty cute.
And
Yeah.
Ed said that he pulled out some volume. He said it was a giant book that he was
Yeah, I
looking
think
at.
that was it. I think it was
That
the
was the Sky Atlas of the 50s.
Yeah, that's it. Thanks, Jerry. That's my story. It was pretty
Okay.
fun.
And if
Yeah.
you go down into the tail of Scorpius, you got that false comet that you can get even eyeball.
Right. Yeah, saw it last night, Chuck.
All right.
One of the clear nights in what, last 100 years here?
I guess we don't
Seems
show,
like
I didn't show the tail of the Scorpius. Oh, there it is right there.
Yeah.
But the false comet's down about here.
That's right. Mhm.
Yeah, you're not sharing, Jerry, so we can't see the image, but
I'm not?
You
No, I
you
can
share
see
it.
it.
Oh, I'm
The
sorry.
image is on the screen.
I'm sorry. I clicked on Zoom to where it was just showing the meeting and not the screen.
Okay.
Panicked me because I'm doing this I'm hanging on to Zoom by my fingernails, and when something goes wrong,
Is this supposed to show us the old bears? Have I missed
No.
that?
we're
Not
coming
yet.
up.
That's
Okay.
coming up.
This was M4, wasn't it?
Oh, there it is.
Mhm.
This is a horrible map. This is from Astronomy.
It's the same map we showed last week. So then we were down here. Now we're up here. So we're close to 2281. Another
Glob.
star
That's an
cluster.
open, I think.
That's an open, yeah. With that symbol, yep.
Yeah.
2419 would be a glob.
That's right, with the cross.
This is an amateur sketch of 2281.
Mhm.
So it looks like it was a windy night. So
It blew all the stars away.
that was just a joke, folks.
Yeah, a windy pen.
Yeah. windy night.
All right, I
Well, you
missed
can tell
something.
because the E over there is distorted by the wind.
Yeah.
Oh,
Yeah.
It was an east wind.
are we looking at a star cluster?
Yes.
Yes, yeah. Mhm.
Oh, okay, with a number, not a name, or what? Well, they don't give them names, do they?
It looks like he used an ioptron mount.
Yeah.
Yeah.
Okay.
And a Meade 20mm eyepiece.
Okay.
Huh.
So he doesn't say the aperture of a scope. When you get these, excuse me just a second. When you get these, NGC 2281, and you mentioned it doesn't have a name. When things get a name, those are all unofficial names. There's no, the Astronomical Society that officially names things like planets and moons and dwarf planets. They don't name these clusters and nebula. Those are just amateur things that catch on, and they change with generations. So,
Okay. And according to Neil deGrasse Tyson, any of the new stuff, they just put a telephone number up there on. Wish they'd do it like I wish they'd do it like we used to do telephone calls. Murray Hill 42211.
Yeah.
Galaxy
you
3.
remember your childhood phone number?
Yeah.
Mhm.
Temple.
Everybody does.
Temple.
Ours was six.
Yeah.
Ours was 680.
Just
3 digits.
you didn't even have a name at the beginning, huh?
Yeah, mine was Florida 35656.
Ours was Walnut.
Walnut.
I
Yeah.
wonder how they came up with those.
There's
Yeah.
Indianapolis. Yeah.
Yeah.
Well,
Santa
they
Barbara
took
was
calls
woodland.
from 680
That's
to
what they're-
Oxford 4680.
That was in an age when they didn't have very many phones compared to now.
Right.
And
Right.
you would have to listen. We were on a party line for a lot of my elementary
They
school.
were also on a party
But we'd
line.
listen to the neighbors talk, and my mother would come in and scold us for doing that.
Wow. That's dating you, Jerry.
Can I ask a dumb question about that picture? Would you go back to it one more time?
Sure.
But we're looking toward the north in this, obviously, because to the west would be the left, and that's the coast of California. To the east goes back that way. North and south would remain the same, up and down. If we were looking south towards San Diego, the W and the E would be reversed, right? How do
I'm
you
not
get
sure I follow
This
that.
is because the telescope he's using flips stuff, Ron. He probably has a diagonal in there or something.
Mhm.
It's hard for me to see west, east, north, and south on the sky. To me, it's either up or down or up
Well, you
and
gotta tilt your head back. This is the way star charts are labeled this way. And
You
you
hold 'em
gotta hold
overhead.
the star chart over your head.
Well, this one
Okay.
wouldn't work.
West, south, and east lines up with.
This one
Your-
wouldn't work that way. because
wouldn't?
he's got a diagonal or something in, right? Because
Right.
Yeah.
think of holding this one up. The W would be to the east if you held it over your head.
Mhm.
Well, I get this comment a lot at star parties. They say, the image in your
You're
scope
right.
is back.
You're right.
I said, no, it's not. I've got a prism diagonal. It's a true image.
Huh. But wouldn't it
Yeah,
be
it depends how
above
many
the
mirrors you've got in your telescope.
Uh-huh.
Say again?
It
Would it be
depends
a-
how many mirrors you have in your telescope.
Okay.
Oh, okay.
Got it. Thank you. NGC 2291 or
2281.
81.
Yeah, but
Yeah.
my 90-degree diagonal is a roof prism, which doesn't flip things right to left.
Really?
That's an older style diagonal.
Samuel L. Jackson or Samuel D. Jackson? Never mind.
What's the newer style diagonal that is a prism that doesn't flip images?
Yeah,
This
but you get more glass that way, so you lose a little light. Not that it's a big deal, but
Yeah.
And this is the
You lose
first
most
quarter.
of the light going through an interface with glass. But with modern coating, and for raw glass, it's about 5% for interface. But with modern coatings, you can cut it down to less than 1% loss.
Wow.
especially with the interference type diagonals.
Yes, oh God, I forgot, dielectric coatings.
Yeah.
Yeah. Those are all breakthrough technologies that have made possible really exotic eyepieces with 100-degree field of view, but they have sometimes like 20 surfaces that light has to go through. And without those coatings, you wouldn't get any light through there if you lose 5% on every interface. But when you make these multi-layer coatings, it's a great opportunity to screw it up. So you got to get a good one, and sometimes they're quite pricey.
Mhm.
Where I worked, we made NASA required very sharp turn-ons and turn-offs to spectral filters. And we were making multi-layer filters with 125 layers.
Wow.
Each one tuned to the right thickness to interfere with the wavelength of light that we wanted to kept out.
Yeah, we did this in the X-ray region, Jerry.
Yeah.
Yeah. At Lockheed Research Labs.
Mhm. Very demanding work. People
Oh,
that
yeah.
can do that are very skilled.
Yeah.
Okay,
So
this
this,
is
go ahead.
first quarter, and when it doubles, it doesn't become a half, it becomes a full, doesn't it?
Yeah, this is the first quarter, and a half is a full,
Yep.
and then a new is a zero. So this is right at first quarter. You can see the terminator is exactly a straight line down here. This is set, this graphic program is set for June 13, which is what, 3 days from now, 11, 12, 13. This is Thursday at 10.
Thursday night. Yeah.
Yeah, that's our 60th wedding anniversary, so I don't think I'll be out looking for this.
Congratulations.
Thank you.
Yeah. Right. I know we haven't got to the Chinese coming back yet. That'll be at the end of the hour, but do you suppose they're going to get to name all the big features that we never see on the other side? Since we
Ron,
got,
that was already done by the Soviet Union in
Right.
1959.
so they all have Russian names over there?
Yep.
A bunch of them,
A
yeah.
lot of them, the big stuff. The biggest crater, I think, is Tsiolkovsky.
I'll be damned. I thought they wanted to concentrate on Venus for some reason during their early space
They
program.
do, but Venus was very rude to their satellites.
Yeah. And Ron, Changi 6 is not, the whole thing did not come back. They're just sending back a return capsule. So Changi 6 is still sitting there on the other side of the moon with a rover.
Oh yeah, well I didn't think they got it all back. We left every one of our landers, didn't we? Apollo. There's about 6 of them on the moon, aren't they? The capsule left it. The lander was behind.
Yeah.
Okay. Here's Saturn.
Now you can see this is a Saturn planetarium graphic. Shows Titan and Rhea transiting the disk of Saturn. It's a poor image here, but Titan is the blob right here, and Rhea, you see the word Ea, that's right here, just coming on the disk. Titan's already halfway across. And this is June 14, so that's, I think, Friday at 4:25 a.m. in the morning.
Yeah, Flag Day.
Okay. And you can see that the rings of Saturn are getting quite narrow. We're coming up on a brief period of no rings. So it'll be a good chance to take a picture of Saturn without the rings in the way.
In March of 2025.
Yeah.
Nobody'd believe it was Saturn if there's no rings.
Yeah.
You
Really
just have to
confused
wait.
Galileo.
Yeah.
Right. Yeah, it's a good thing he didn't look at Saturn right away, you know, at the right time, just coincidental. So he went to his grave wondering why there was a planet with handles on it.
Right. He
Ears.
called them, yeah, Latin onse.
Now, Jerry, would there be shadows? Is Rhea
Yes.
too small to throw the shadow, or is it
But not necessarily on the disk at the same time that the transit occurs.
okay?
Really? Why?
Because the sun
Angles.
angle isn't directly on.
Oh,
If Saturn were right at opposition, then you'd see the shadow near the occulting object. Because you'd be looking down on the planet,
got-
like same angle the sun is shining at.
Mhm.
Gotcha. That's what I. Yeah. Okay.
Okay.
well, what's it? Okay, here we go. This Boeing?
This is a picture of the Starliner, Boeing Starliner, and it is docked to the ISS, and it made it up there with it had thruster problems and more helium leak. Apparently they use non-reactive or non-hot gases in their jets to do attitude control. They use helium. So they have, and helium is hard to keep in a container because it has these little teeny round molecules, or not molecules, but atoms, and it goes through just about everything. That's why your helium balloon, the day after you bring it back, if it's not a metal balloon, it's all shriveled and down on the floor because all the helium leaked out through the rubber balloon.
Huh. I didn't know that.
They did. They
That's
were aware of all
expensive
these
fuel.
issues as they went up, but they continued.
That's expensive fuel to use, really.
It is. And we have such a limited supply of helium-4.
Well, would it be more expensive than rocket fuel that's actually burning flames?
Yes.
Yeah.
Yes.
Really?
But you don't want the byproducts of that getting all over things you're kind of trying to dock with.
Yeah.
Well,
When I was in graduate school, we used helium as a coolant, liquid helium, and we were told to treat it as if it were expensive cognac.
Yeah.
okay. Well, I keep hearing, or I have heard in the past, that we're running out of helium. You'd think there'd be a way to make it.
No, well, there is fusion,
Yeah.
but and the sun is doing its best.
And they get it out of the ground?
We get it as a byproduct of methane and gas wells.
Yeah, natural gas.
And I guess they found a big deposit of it in some place like Minnesota. So trapped under a rock shield, kind of like a gas formation. And so there is going to be better supply in the future, apparently.
Yeah. And the US is the major supplier of it.
But
So-
now underwater people that are manning these submersibles breathe helium with air, don't they? They don't do that with the astronauts, right? They're not.
Well, they have a helium oxygen mixture. They get they don't want the nitrogen.
Yeah.
Yeah.
That's what it is. Okay.
Nitrogen under pressure becomes a narcotic.
Okay.
Now,
Because
is there an alternative fuel that they can use other than helium?
I'm sure there is. But
Hydrogen.
This is optimum.
lithium number 3 is not a gas at all, is it? It's a metal, isn't it?
Depends on the
Everything-
temperature and pressure.
Yeah, it depends. Everything is either a gas, solid, liquid, or a plasma. It
I know,
depends
but
on
it's
pressure and temperature.
After 2 gases, suddenly it becomes not a gas in its normal state. Lithium, it's
In our what we consider our normal state, yeah.
Helium is a inert gas. Its electron shells are full. It doesn't react readily with anything else. And lithium is missing an electron. It has one extra electron, and it's very reactive. You do not want that anywhere near your system.
I missed what that was.
Lithium.
Lithium.
It's got 3 protons, right?
Yes,
Okay, it's
3
number
protons, 3 neutrons,
3,
and 3 electrons.
and the old element table goes right past it. right onto carbon and oxygen if it can? Is that? We got whole deserts full of that stuff, don't we? Elon Musk is trying to sell money to go mine lithium on different places.
Yeah.
We're down by the Salton Sea.
There are
Yeah.
new battery technologies coming online that do not depend on lithium.
Yeah.
But we have a
And-
major lithium find in the US. The US is one of the major producers of lithium.
Yeah, and Tim, you know that, they're experimenting for much better lift with upsidasium, right?
I thought that was in the category of unobtainium.
Yeah.
Yeah.
And going back to what the astronauts are breathing, the big Apollo 1 disaster was because they were breathing pure oxygen,
Yeah.
Yeah.
and there was
Yes.
a static spark, and it ignited, and it ignited all the interior materials and
Yeah.
killed Grissom and the other
They keep the
astronauts.
inside of the Apollo things, they kept them at 5 PSI, where atmospheric
Right.
pressure is 15.
Well, I got news for you. A lot of old folks lay in bed breathing just that too, if they can.
That's why hospitals are really nervous about people, smoking or trying to sneak a cigarette into rooms where people are breathing pure oxygen.
Oh boy. Oh boy.
But a spark made all that oxygen suddenly combine with what, the metal parts, or just the?
Well, there were non-metal parts too, just I don't know, phenolics and things that they use for some of the structure that ignited.
They got
Pure
cushions.
oxygen atmosphere makes almost anything flammable.
Yeah.
Upsidasium.
I remember college chemistry. Powell was our professor, and he had liquid oxygen there, and he was doing things with it. And it was after the class was over, one of the students came up and dipped a cigarette in it, took it out, and was about to light it. And Powell says, "You really don't want to do that. Put it down and light it." And it went off like a flare.
Yeah.
Oh, hey, this is not Starlighter. This is
There's
called
there's one other mineral you may have heard about. When miners are looking for gold, they frequently find a mineral called leverite. And if you find that, it's not of any value, so you leave her right where you found her.
These are good.
Okay.
not iron
Okay.
pyrite.
This
Okay.
is the Starship. Yeah, Starship.
Starship. Not even going to the stars, but that's a good name. It's taken.
And this is launched from Corpus Christi, Texas, not from Florida. They're doing their own launching. These
Nobody on it.
these things here sticking out and one over there. Structures like these are going to grab the booster when it comes back. They're called the chopsticks. They haven't been tested yet for a real flight. And this is the Starship up here and the booster down here, and the flame coming out. And this is the takeoff or liftoff from Texas. Now,
And Ron, the Starship did not get recovered. It was only the booster that was recovered. The Starship splashed down in the ocean.
Okay, the bottom half of what we're looking at right there, what we just saw go away.
No, I
Yeah.
thought, Jerry, I thought those pinchers were supposed to capture the Starship on when it came back.
the booster when it comes back.
It's up there, but I thought it was the Starship itself. Where they were gonna.
Yeah, the boost landed on a barge.
Yeah.
Well, you know what I like about it? My early youth pictures of rocket ships, they all had fins, and then the real life stuff, no fins, except for this one. Finally, it's got fins, but that would be the part I would think could fly back like the shuttle.
They're not depending
that's
on
when
the
you're doing
lift.
aerodynamic stuff.
Yeah.
So they lost the capsule with the fins.
Yeah.
It just fell into the Gulf of Mexico.
No, I think it
Indian
was the
Ocean.
Indian Ocean.
Oh, this was launched from Florida.
No, it was
No,
launched from Texas.
Texas, right.
Oh, it
Yeah.
was.
Yeah.
Oh, okay.
So you can see one of its engines on takeoff was not
Yeah,
the
redo that,
ducted
Jerry.
engine.
It's hard to see.
Yeah, the contrast levels changed when you put it up.
Yeah, you redo
It
it.
was good, and it went bad.
Huh.
Maybe
When I
if you
saw,
don't boost it, make it smaller.
Okay.
That works.
What is it?
Well, let me make it smaller.
All I see is white.
Yeah.
Do you
Okay,
have
well, we'll move on.
two versions of that? Because one you put up, you
There
can
it
see the individual rocket motors easily.
Huh.
Yeah.
Interesting.
Okay. This is, well, it's in space. The booster has, I think the booster has separated.
Yeah.
And this is the Starship itself showing one of its fins and the tiles on here.
Hmm.
And the problem they had with it was it lost its tiles. And this is showing the camera mounted on the front of the Starship or on the back, somewhat part way down. And this you can see that only part of the skin is covered with the tiles. The upper part is not taking the heat. And these tiles up in here, apparently some of those came loose. And one of these fins actually burned through shortly after this picture was taken.
Yeah.
You know, that might have been, maybe those tiles is what let that burn into the fin, because it didn't get the whole fin. It entered from the bottom
Yeah,
where those tiles are.
where the tiles were supposed to be.
Yeah.
Yeah.
So maybe that's all they got to fix is that.
This is a very confusing picture, but this was purported to show the actual fin here, and at the base of the fin, it's actually burned into the metal.
Yeah. Yeah.
So fin tiles have come off. This is one of the reasons they retired the space shuttle. The tiles were so problematic and so fragile.
Well, what we're looking at here is what killed all those people in the second shuttle disaster, not the first going in, but coming back.
Yeah. Yeah.
Burned them
Well,
all.
after that, they had a repair kit on board just in case they had to go,
Yeah.
replace the valve.
And, and after that one, the space shuttle would move off the ISS and then rotate completely around so people in the ISS could inspect for missing tiles.
Yeah, that's it. That's it. Yeah, I don't know what the fix for that's going to be, but that is a problem.
Well, okay,
So
go ahead.
Okay, the Starship took off with the booster. Starship separated from the booster. The booster landed and was recovered. The Starship went on to the Indian Ocean. It did a complete reentry gymnastic thing that it's supposed to do, and it made a soft landing into the water. That is, it came down butt first, and it fired its rockets to where it stopped into the ocean, but there was no ship there, so then it just fell in the ocean.
And we've lost it.
Yeah.
And this is how all of the SpaceX, they get the booster back and it lands sometimes on a barge, sometimes right there at Vandenberg.
Yeah.
Yep.
Yeah.
And what I don't understand is the sonic boom, meaning it breaks the sound barrier that we get, is on that coming back. I don't understand. That seems to me it'd be going a lot faster pushing than stopping and slowing down and then settling back down to Earth. Why would that go so fast?
The rumble you hear when they launch it, a lot of that is sonic booms.
Well,
they're continuous.
It's not a rumble. Sonic booms are passing the speed of sound.
Yes. And a lot of that rumble you hear is a bunch of little sonic booms because the thing is constantly at above the speed of sound. But then when you've got the booster coming back, it just briefly exceeds it and you get a sharper boom.
So somewhere in that arc, right about the time it puts whatever the forward part in space, it stops and creeps backwards or fires backwards somehow.
Yeah. It has retro rockets that slow it back down and then it just free falls.
I'd love to see a video of how it works.
Okay, I'll find one.
I was fortunate to see this live, and when it came down, they thought they lost the fin, and apparently they didn't, because they said that when it was coming back in and did the soft landing, they were shocked that they saw it.
They were surprised. The fin was destroyed basically, but it still worked. It was,
and they were stable. They said it was stable when it came down. It wasn't rotating out of control.
Still under control.
Yeah, unbelievable.
Now, when it goes up. It starts in the dense atmosphere and it goes up very quickly to very thin atmosphere where you're not going to get a sonic boom up there high enough. When it comes back, it's coming back at a very high speed and it's coming down into the denser atmosphere when it's still supersonic.
But does the fact that it has fins on it mean they want to get the capsule back?
Yes, everything here is supposed to be recoverable. That's the cost advantage of this. That's the key contribution that Elon Musk is making to space travel. Is
And
all
one of the most
reusable.
fascinating things that we were looking at on this live, reentry, is the altitude they were at and the speed that they were going at, and when that changed. Because so they kind of skipped for a while, and then there's a point where the temperatures get to maximum. It was really fascinating. It was something to see.
I think this is the Euclid, right?
Mhm.
This is Euclid.
Okay. I know it well. One of many space telescopes up there. The ESA is behind that, but they launched it from here, didn't they?
Yes, I believe so.
Looks like it has a
Yeah.
wall on the side. Is that a
Yeah,
big
New York
sport?
Times, Ron, New York Times last week had a fabulous story. In the Science Times Tuesday last week,
Okay.
it's really good on this telescope. And some of the images that they're getting to study, dark matter, things like that.
Hmm.
And dark energy too.
Yeah,
Good.
this
ahead.
is stationary now at the L2 Lagrange point, along
Mhm.
with James Webb Space Telescope. And its specific mission is to try and find things about the evolution of the universe that are applicable to dark matter and dark energy.
Mhm.
Applicable.
Mhm.
What does that mean? You mean
That give you information about.
Yeah, that is applied.
they can't see it, but they can
Oh,
find
but
it
they
and
can
know it's
see its
there?
effect. They're looking specifically at the shapes of galaxies at varying
Yes.
distances from Earth
Mhm.
and the distance and redshift, the relationship between distance and redshift. You recall there are two different ways of measuring redshift and the Hubble constant, and they do not agree.
Right.
So
Hmm.
this is directly looking at that relationship.
There's like 3 or 4 different ways of measuring it, and they clump into 2 different values. So that's
Right.
what the big worry is.
Okay. Did they find galaxies that they don't think had any dark matter in them?
They did find one, I saw that, but I didn't explore it much.
Wow. Okay. Is that it for the Euclid, or are we still on
No,
this?
that was a Euclid view of a galaxy cluster.
Isn't that something? You can see
Yeah.
the mirror segmented.
Yeah.
Yeah, it's like Hubble, it's going to be a faceted 6 hexagonal mirror cell thing.
Like Webb. Like Webb.
Like Webb,
Like
excuse
Webb.
me.
Yes, yes.
God, there's so many
Wasn't
up there
this
to
like
mix them up.
50,000 galaxies?
Yeah, it's an amazing scope.
And each one of these has a little curve thing, the bright one, a curved diffraction spike.
Wow.
I don't know what that's due to. Probably some part. Maybe it has a secondary spider that's curved. And you can see little Einstein arcs and rings here.
Yeah,
The next picture is a close-up of the center section here.
look
Wow.
at that.
And you can see these Einstein rings, whoops, and these really distant redshifted galaxies.
Mhm.
Okay. Well, maybe I missed it. The 6 points are because it's a hexagonal shaped lens?
Yeah, that's a hexagonal shaped mirror segments.
I'll be
Right.
damned.
Yeah, a collection of mirrors, Ron.
Yeah.
Oh, just like the Webb.
Yes.
Yeah.
Yes, that's right. But I don't think it's big, right,
No,
Chuck?
it's not as big.
Yeah,
Yeah,
okay.
it's small.
And it's not as its sensors are not as cold. This operates in the visible and near IR.
Right, right. Yeah.
And when did they put it up?
Last summer?
You mean after the Webb went up?
Yeah.
Oh, yeah,
that-
yeah. The Webb is like December of what, 22?
Something like that. Yeah, it was right around Christmas time.
Mm-hmm.
Oh, okay. And it probably didn't cost $10 billion. It's
Yeah.
still probably a few.
It was launched on July 1st, 2023 from Cape Canaveral.
Okay.
Wow.
Yeah. Jerry, if you have 1 minute, it's something completely off topic. So there was also recently in the New York Times science section a write-up about the Simons array down in the Atacama Desert in Chile. And this is a So millimeter collection telescopes. And it turns out in the article, by mentioning the Simons array, it turns out Jennifer Ito is working with the telescopes. It's really interesting out of Westmont.
Okay.
So, and what they're trying to do is either scrap or keep inflation by studying basically magnetic structure in the universe that is basically imprinted through gravitation, through the gravitational explosion. Really interesting article.
There is a hypothesis that inflation is an
That is right.
optical
That's right.
illusion.
Yeah. Yeah, that goes back to the 80s, with Alan Guth when he was at Stanford. Anyway, that's my little spot.
Okay.
Read the New York Times. This is great. It's good stuff.
Now this is a photograph taken by the Chang'e 6, the Chinese spacecraft that's landed on the backside of the moon. And it launched, as it landed, it launched a small photographic instrument that landed a short distance away and took this picture.
Mhm.
It has taken several samples of the soil there, and they're on their way back to Earth now. But this spacecraft is still there.
The upper part of this thing we're looking at blasted off just like the Apollos did.
I don't know which part of it did. That could be like that. The article wasn't specific. I had to glean a lot of information. It's mostly bragging about how landing on the moon is unprecedented. Chinese did it first.
Yeah.
So,
Yeah, well, I think I see the solar panels sticking out, but that arm on the left, is that what dug down and grabbed whatever it could?
yes, that is what it's got there is an ampule with the samples in it.
I thought it was an empty vodka bottle.
No, that was the Russian spacecraft.
Yeah, okay.
We littered the Earth and we filled the debris field around us. Now it's time to go make a mess out of the moon, everybody.
Yeah.
Great picture, great hour.
Yeah.
I learned a lot. Gentlemen, we've reached the end and now it's time to say goodbye, but that was 172. Next week it'll be 173. And there's a lot going on. I can tell you, or Chuck can tell you, I guess tomorrow night is both the workshop and Camino Real, Telescope Tuesday,
Telescope
right?
Tuesday.
And Thursday, I'm going to give Sandy Steele a plug. Her LCO meeting downtown is Thursday of this week at a place called M Special, about 7:30 at night, I think, in the back there. They have a little speech. And then Friday is our meeting, second Friday this month, with the man to my right on the screen doing, I guess, a talk about the moons of the solar system, Chuck.
The Lunatic Express.
That's right. Well, let's meet again, gentlemen, and take care of your wives, and we'll see you at all kinds of outreach. We'll